Hello everyone and welcome. My name is Gurudi Etienne and I'm a Senior Product Manager here at MongoDB. And with me is Max Hirschhorn, an engineering lead on the sharding team. And today we're going to talk to you about live resharding, a feature we've worked so hard to deliver in MongoDB 5.0. Today's agenda. First thing is we'll talk to you about live resharding by giving you an overview. Then we'll talk about how our customers reshard today. Next, we'll talk about how MongoDB's live resharding works. And lastly, Max will give you a demo that he's worked so hard to put together. Before we start, I want to make sure we're on the same page. We understand that choosing the right shard key is critical to your data distribution strategy. And with that said, what is the goal of live resharding? It's to allow you to change your shard key. But not just that. You get to do it on demand, with no downtime, and with no application changes. What is the value of live resharding to you as a user and a customer? First is you get to evolve with your apps with simplicity and resilience. Now you can reshard your MongoDB collections with no downtime. As your applications evolve or as you need to improve on the original choice of a shard key, a single command will kick off resharding. The process is automated, resilient, non-disruptive to your applications and users. Second value is flexibility and agility across every layer of your application. You have seen how MongoDB's flexible document data model instantly adapts as you add new features to your application. Now you get that same flexibility when you shard. New features, new requirements, simply reshard as and when you need to. Third, you get to compress what took weeks and months to minutes or hours. Live resharding is fully automated, so you eliminate disruptive and lengthy manual data migrations. To make scaling out even easier, now you can evaluate the effectiveness of different shard keys in development or test environments before committing your choice to production. And even then, you can change your shard key whenever you want. So what exactly is live resharding? It's the ability to easily change the shard key of a sharded collection. You do that in place, so no downtime or application changes. You can do that between any combination of shard keys. You can go from a compound hash shard key to a range shard key and vice versa. From a range shard key to another range shard key, vice versa. Range shard key to hash shard key, vice versa. Basically, if you can shard on it, you can reshard on it. Now you get to test different keys in your development environment. And lastly, really the big all, is that you get peace of mind. You no longer have to worry about being stuck with the wrong shard key. So let's get into an example to really solidify our understanding of live resharding. Let's say you have an orders collection, so you shard an order ID. However, as you grow, you find that the majority of orders come from a minority of large, repeat customers, and you want to be able to regularly query a single customer's orders to display order history. In that case, it would make sense to have orders for each customer localized to a shard, so you avoid scatter-gather across shard queries. And you realize that you should have sharded on customer ID and order ID rather than just order ID. Now, you get to do that with resharding with zero downtime, zero unnecessary risk, it's agile and adaptable to applications, and it's fully automated. So when do you benefit from resharding? There are a few situations where we think you could find resharding beneficial. One is high latency. Maybe your queries are not performant because they're not targeting specific shards. Another scenario is hot shards. Maybe your data or your workload, they're not evenly distributed across all shards, so you have one shard or a subset of shards doing the majority of the reads and writes, and you're not fully taking advantage of all your other shards. Or maybe your workloads simply have changed. Your application has evolved, and what was once inadequate shard key is no longer adequate. Lastly, you get optionality. Maybe you're not sure which shard key to choose, and you want to be able to test several shard keys so that you settle on the best one. What are some of the customer pains that we think resharding will address? And speaking of customers, there are really two groups of pains that stood out. The first one is that users are afraid to shard. One customer said, for example, to be frank, some of our teams don't want to shard because they don't want to be stuck with the wrong shard key. Another customer told us, we have a testing lab where we shard repeatedly, but resharding would give the rest of our teams a great deal of confidence. So really, it's about being reassured and feeling better and making sure that you're not stuck with the wrong shard key. And so a corollary to that is a lot of customers have sharded on the wrong shard key, and they really would like this problem to be solved. One customer told us, we have a 2.7 terabyte collection where the existing shard key we chose simply isn't good enough. Another customer asked us, how do we change the shard key for our customers who picked the wrong shard keys? So what they do is they shard for their customers, and they think some of those customers have picked the wrong shard key, but they don't want to bring that up to them because there's no easy way to reshard today. Which brings us to the next segment. How do our customers reshard today? Let's talk about manual resharding. Manual resharding inhibits agility and innovation. And so as customers' apps evolve, it is impossible to quickly change shard keys and be responsive to end user changes. What are the challenges of manual resharding? Before we get into that, I'd like to reiterate that choosing the right shard key is critical to the right distribution strategy. Today, changing a shard key is a manual process that can involve downtime. There are really two main approaches to manual resharding today. The first one is dumping the entire database and reloading it to a new resharded collection. The second approach is executing a custom migration, also called a live migration. So dumping and reloading, how does that really work? So you have your cluster that's currently serving your reads and writes. You take it offline, you reshard manually offline, and you reload it with the new shard key in a new cluster. This one is relatively simple. And so what is the main downside? Downtime. It normally takes 2 to 3 days to reload a 10 terabyte cluster across 3 shards. And so live migration. Live migration, first I want to call out that they're complex, risky, and expensive. So how does it work? You keep your old cluster up to serve reads and writes. At the same time, you spin up a new cluster that's also serving the same reads and the same writes. You're just copying over all the data and the workload. And once that new cluster is caught up to the old cluster, is behaving the same way, you switch over to the new cluster and you delete the old one. So what are the consequences there? First one is cost. You're doubling up on everything, hardware, licenses, etc. So you got to pay twice the cost for that. It's also complex and risky. Writing query, routing, and migration logic, constantly checking on the migration progress, and checking that no data has been lost, that's no easy feat. Third, even if you get all that right, it's time consuming. It took 3 months for one customer to migrate 10 billion documents with a new shard key between the old and the new cluster using live migration. So how does MongoDB's resharding work? First, let's talk about the syntax. It's very simple. You run reshard collection with your collection name and the new shard key that you want. That's it. There's nothing else to it, really. Let's look at an example of what's happening under the hood. Let's take that same orders collection that we had that was sharded on order ID. And let's say because of that, that shard 1 had 78% of the load, while shard 2 had only 22% of the load. And what you were looking for was a more even distribution of that workload. And as we said before, you've identified the new shard key, its customer ID and order ID. So the way MongoDB reshards is, it copies the collection into a new collection, shards that collection by customer ID and order ID. And then once that collection is ready, we delete the old one and keep the new one. Once you do that, you're now sharded on customer ID and order ID. And as you can see, you get a more even distribution of your workload. But I'll let Max go into more detail into how exactly we do the cloning and resharding. To you, Max.
Thanks, Grudy. Hey, everybody. So I'll be showing resharding in action. So I have a 3-sharded cluster set up and a sharded collection called orders. The orders collection is sharded on order ID. So what I'm going to do is I'm going to run a find command just to show you what some of the documents in the orders collection look like there's a padding field to make the documents a little larger so that the whole collection's around 2 gigabytes. So all the documents have an order ID and a customer ID, along with some information about the order. Next, we'll switch over to the other tab, where I will first start by running a script in the background. This script is going to do some writes on the orders collection for while the resharding operation is going on. And then I'll run a second script that'll actually show the progress of the resharding operation. It won't show anything interesting just yet because we haven't actually started resharding yet. So now I'll switch on back over to the Mongo SH tab, where we'll actually run the reshard collection command. So we're going to change the shard key from being order ID to being customer ID followed by order ID, like Rudy was mentioning earlier. So we're going to go ahead and just type up this reshard collection command and then kick that off here. So once that's running, we'll go ahead and switch on over back to the monitor tab, and we can see that the monitor has already picked up on that there's a resharding operation in progress. So each shard is going to begin by collecting an initial copy of the data. And so as Grudy had also mentioned before, that new copy is written into a new collection. It'll be sharded by the new shard key. And after the shards make that initial copy, they'll then apply all of the changes that had happened while resharding has been going on. And so you can also see that each of the shards are also fetching all of the oplog entries, which represent all of the changes that have been happening to the original collection. And then once a shard finishes cloning, it'll begin by applying those changes to the collection. And so we can see that one of the shards has finished cloning, so then it begins applying, and then the other shards also finish cloning and then also begin applying. And they'll continue to continuously fetch and apply all of these operations, and the coordinator will look for an opportune moment to finish the resharding operation that minimizes the impact on the running application. So we'll see that the shards continue to fetch and apply, and eventually the coordinator will go ahead and commit the operation. Great, so it looks like resharding is finished. We'll switch on back over to the Mongo SH tab, where I'll show by running SH status again that our shard key is now customer ID followed by order ID. That's it from me. Back over to you, Grudy.
Thanks, Max. That's really it from us. Hopefully you enjoyed this talk. If you have any questions, feel free to reach out to myself or Max. And also make sure to check out all the other talks at MongoDB Live this year. Thank you.